morning, good afternoon, good evening to whichever part of the world you are from. Today, we're here with yet another wonderful session with Megan. Before we start with today's session, I would like to introduce and talk about WIDS, with whom we've collaborated as our platform partners. So, WIDS, what started as a one-day technical conference, has actually reached out to having more than 150 regional events worldwide with more than 60 countries and 1 lakh participants participating annually. WIDS conducts datathons, podcast series, education outreach programs, and workshop series. And to highlight this year's event, which was Women's Day conference that they had organized, it was a 24-hour conference with global audience and having networking events and sessions parallelly. Today's session, we have collaborated with WIDS Brussels, which was started in the year 2021. We have our two beautiful ambassadors, Maya and Aarti. Maya is a professor at VUB and Aarti is a data scientist at Alliance. So we have collaborated with them for 8 sessions, which would be happening this month as a part of their celebration for Women's Day. The agenda is spread over, and we would be sharing these details regularly with you. Now, let's quickly go over to our speaker, who is Megan Bloemsma. She is a data scientist working with Microsoft. She's a passionate data scientist, and she loves working with data. She tries bringing in diversity into the tech industry. And here, I hand over the session to Megan.
Yeah, thank you so much. So you should be able to see my screen. Awesome. Thank you so much for the introduction. I'm really excited to be here today. The Women in Data Science community is one that I've been following for a couple of years now. So I'm also very excited that there's one in Brussels and in Belgium now as well. I'm going to be talking today about kind of data science in the real world and what are the challenges and opportunities that we can find there. There will be some time for questions at the end. I won't be able to see your comments until the end or until I'm interrupted. But yeah, I'm really looking forward to that. So to start off with, I just want to introduce myself shortly. So my name is Megan Bloemsma. I've been working at Microsoft for 4.5 years now. I started working there immediately after my studies. So I did a master's in data science, and my role title seems to change every year, but I'm a partner technology strategist for ISVs. And this means that it's my job to help independent software vendors or companies that build software. I'm going to help them on a technical level. That means I don't just help them with data science and artificial intelligence. I help them with Azure everything, which is a huge challenge, but I have a really nice team around me where everybody has their own specialism, so that works out. And I mostly sit down with the CTOs of these companies. So I'm really trying to look at them with them from a strategic level. How can we innovate their company, specializing in everything data science? So, as I said, I've been working in this field for about 4.5 years, almost 5 now. And coming from I would say, quite traditional academic background in data science, I've encountered many hurdles over the year with trying to apply data science in business over the years. On top of that, something that has been happening for the last couple of years is that I'm really seeing the data scientist role change. So this is something I want to discuss today. So the agenda looks kind of like this. I first want to come to a consensus on what actually is data science. Then I want to talk about adapting data science to a business environment, about a data scientist 2.0 and how I see the role changing currently. We're going to be talking about MLops. And as I said, we'll have room at the end for questions. Just put your questions in the meeting chat as they come along. And if there are really urgent questions, I'm sure somebody will interrupt me and we can answer that on the spot. So to start off with, what is data science? And I know this is a really weird thing to start off with in a presentation, especially for a community of data scientists. But the reason I'm doing that is because I've noticed that with the companies that I'm speaking to, data science has a different meaning to all of them. For some people and for some companies, data science is a Power BI dashboard. And for others, data science only is like a custom code algorithm that they've built. So, and actually, I use this slide for almost every presentation that I give, also externally, internally, which is what is data science to me? And for me, data science is nothing more than the processing of information. So you have data points, and you're trying to find some kind of pattern or trying to get some insights out of this data. I tend to describe artificial intelligence as a bomb-sniffing dog. And what I exactly mean with that and why I explain that way is because what you do with a bomb-sniffing dog, and those are the dogs that there are at the airports, is that to track drugs, is the only thing you do is you teach that dog, if I smell a certain scent, I need to bark. And if I bark, I get a cookie. And in a way, actually, AI and algorithms work the same way. So you actually need to teach an algorithm what to do, right? And it's what we do in training. There still seems to be this idea at a lot of companies that data science is kind of a magic black hole where you get this magic unicorn data scientist in and they do their thing, something with code, and then an algorithm or something comes out of it and it starts making money. And as you probably all know, that's really not the way it works. And you need to have a very clear view of what you want your algorithm to do. So do you want it to do predictions? Should it do classifications? Should it do translation, etc.? So that's what you train it for. And then in the second step is when you test it to see how accurate it actually is in doing that task. So the thing I want to talk about is adapting data science to a business environment, because I've kind of learned the hard way that academic data science, how I was trained to do data science, is not the same thing as applied data science. And when I'm talking about applied data science, that's just what I call doing data science in the field or in a business. So this is me, bright-eyed, coming from university. And what I really learned during my studies there in data science is, of course, it's very research-focused. So what you're mostly doing is you're setting out hypotheses and you're validating those hypotheses. You have a working theory on how something can be classified better, on how something will work, and you test it. And the way you do it is with a data set. So you usually have a sample data set, or if you're lucky, a really large, good data set that you do need to do some pre-processing around, but it's quite static. So you just have one set and that's what you work with. The job that I do now is much more applied data science because it needs to be applied to business needs and it needs to be applied to a use case. And that really shifts the way you do your work, because you're no longer just doing research. You're building a model or an algorithm that needs to do something. The data set is usually not static. It's either an incoming flow of data, or it's data that gets updated every once in a while. And sometimes you have to work with real-time data. That's data that gets updated maybe every minute or maybe every hour. And that's a different way of working with it. On top of that, your model needs to go into production. And we'll talk a lot about what that actually means, but it's a different way of, it's kind of you working on your code and on your model by your own, wherever you're working, versus it needing to be shipped somewhere, virtually, of course, and it having to do something and be applied to something. And because the data is so fluent, it also means that your model will need continuous improvement. So things like data drift, or what do you actually do with all this data that just keeps adding up? And so it brings a lot of challenges. And one of the challenges is at least for me, and you'll notice why I'm saying me a lot is, of course, I only have my own experience. So I have the experience of me coming out of school as a traditional academic data scientist and working in the field. And through my job over the last couple of years, I've been lucky to work with dozens of companies and trying to apply data science. So these are the things that I've encountered, but it might be different for you. And it's what I would really love to hear kind of at the end to get a discussion going, because I'm dying to know how it is for all of you. But one of the first challenges that I encountered was collaboration and version control. When I was learning about data science at uni, it was very much about me working on the code alone, locally on my laptop, which sometimes would take hours. And version control, actually, I might have been doing it unconsciously, but I definitely wasn't doing it consciously, right? So it's about working together on code with multiple people, and maybe people who are not just data scientists. It's about code quality and readability of code. But it's also about working with Git and branching and merging branches and kind of more the software engineering or developer side of things. A second challenge is functionality, because just testing out a hypothesis really isn't enough. What will your model actually do, and what will its output be, and how can we apply this to a business case? I think it's a great thing if you're building, for example, an image recognition model and you're working at, I don't know, a retail company. And it's great if your recognition model is able to reach, let's say, 80% accuracy, but what does it actually mean? And what are we applying it to? Because it's really awesome that we can now recognize through images whether something is a baggy jean or a skinny jean, but how will that actually help the customer? And then the last thing is the productionizing of models. So again, like, how do you deal with data drift? How do you deal with real-time data? How do you monitor it? And as soon as you go into monitoring, there's new topics coming into the conversation, right? It's about infrastructure, it's about security. And it's also about collaborating with different departments which are not data science. And all of this is pretty overwhelming. I've noticed that for the last couple of years as well. And not to add the pressure, but something I'm really seeing as well is that companies have been investing a lot in data science over the last years, because data science has been hyped. It's the new gold. It's the new oil. It's, data is money. If you don't do something with your data now, your company won't exist in a couple of years. And I think that's all great. But kind of the first early adopters of companies that really invested in these departments are getting to the point now, let's say 3 to 5 years later, where they're really saying, so we've invested $1 million in this data science department, and we found these data scientists and they are producing models, but we're not getting the return of investment. So that department isn't actually making money. We're not able to use their models and make them into new features. And unfortunately, for some companies, that means they're already starting to scrap the data science departments. And that is something we'll talk about a little bit, is why I think we're going to have this data scientist 2.0, because even though in a way, it's not really our problem that they're not getting the return of investment. And you can say that it's your manager's problem or it's the company's problem that they don't have a strategy for it. But it is a problem as soon as we're getting fired or as soon as we're not doing our jobs, right? And something I want to touch briefly upon is that what I learned at uni as well is building my own custom code algorithms. But there's much more in life than that. Nowadays, and I'm working for Microsoft, so I'm going to be talking a lot about the Azure side of things. But we have the same things in GCP and AWS and a lot of other places. And there's a lot more nowadays already coming out of the box. And that's called the pre-built AI. But there's also things that we call simplified machine learning, that will make your model, you can build it easier. So I just want to give you kind of a couple of examples for that, because even if you do know exactly what you're doing, these can be very handy tools to use. And the first one I want to kind of dig into, it's called AutoML. And AutoML is a tool, and in this case, again, like from a Microsoft perspective, it's built into Azure Machine Learning. It's a tool that can help you choose the right mathematical model. So you can see in the image here, you kind of put in your data set, you say what you want to do with it, and it will parallel run multiple algorithms and tell you which one has the best results. And this is a really nice way if you're still in an experiment phase that will save you some time and kind of do the work for you. And because it's doing a parallel compute, which means it's doing them all at the same time, it can really save you some time. The next one is more the visual interface. And these are more being marketed towards what we call citizen data scientists, which is really about people who maybe not necessarily are data scientists themselves. Maybe they're analysts or maybe they're BI people that do want to do data science. So in fact, what you see here is something called Azure ML Designer. And it's literally a drag and drop environment where you can say, this is my data set and I want to clean some missing data and I want to do this, and it will do the work for you in the back. But to be honest, even as a data scientist, I sometimes use this simply because it saves me time. Because in here, for example, they have an out-of-the-box solution for cleaning missing data. And I'm happy to run that when I'm still in the experiment phase just to see what it comes up with, so I don't have to write the code myself. And the last thing I want to talk about is machine learning notebooks, which is basically like Jupyter notebooks, but then on specific cloud environments. I'm hoping you guys are already working with notebooks because they're really awesome. But when I was still studying at uni, they never told me about cloud compute. And that meant that for my thesis, I was writing code and it had to run throughout the night, and I just had to pray to the gods that my laptop would not go on standby or would shut down, because that means it would stop my code process and I would have lost many hours of valuable time. And then I was talking a little bit about pre-built AI, and again, I think these are really nice tools to use. And the Azure version is called Cognitive Services. Google has these, Amazon has these. There are many companies building these. And they can basically, they're APIs, so you can call to them and they will run the algorithm for you. And we have them for vision. That means you can do like image recognition, face recognition. You can build your own custom models. We have them for language, and we have them for speech, for decision. And there's all these kinds of things that can really help. And I just want to give you an example for this, because when I started working at Microsoft, I was working with this company that was basically doing image recognition to read certain meters. And they had built their own image recognition model, and they've been working on it for, I think, 8 months. And they reached a pretty nice accuracy. I think the model had about 69% accuracy. And again, like, they worked multiple months on it. And when they came to me, they were kind of asking me, how can we improve that that accuracy? But we were also talking about how can we speed up the process, because 8 months is a lot of money and a lot of time to build a model, right? And I told them, take a look at the custom vision. So custom vision is where you upload your own images, and it's again like kind of drag and drop, and you say what it needs to read. And we did a 3-day experiment with it. And within 3 days, they built that same model that reached 63% accuracy. So there was only a 6% difference, but time-wise, it saved them 7 months and let's say 25 days, which is huge. So even if you do know what you're doing and you love building custom code, take a look at these, because they can just kind of save you time in the steps in between. And the data scientist 2.0. Let's talk about it, because I just talked about the difference between academic and applied data science. And I really think that the role is changing because companies aren't getting their return of investment, and because there are different expectations now. So because of the challenges we just mentioned, it's kind of that the responsibilities of the data scientists are changing. And you can already see that happening with the many, many new roles that are appearing everywhere. I don't know how many of you are maybe still students and are looking for a job, or that are already working and are looking for a new challenge. But nowadays, there are so many new titles. There are data architects, ML engineers, ML architects, there are data science managers, there are decision scientists, there are BI consultants, there are data visualizations consultants. And to be honest, to me, it feels like these new role titles are popping up everywhere, and we haven't really found a consensus yet on these are the 5 roles that we think you need. So I think this is just a sign that things are changing a little bit. And as I said, new responsibilities have been added to the role. And I can only speak for myself, but I just kind of want to share with you the experience that I had and with what I meant. So when I started working at Microsoft, I was just out of college. In fact, I was still finishing up my thesis when I started off. And I was working with one of my first customers, and they showed me their architecture. One, I had never seen architecture before because I'm a data scientist and I'm not like a solutions architect. And they were like, yeah, Megan, this is our architecture. What can we improve? And I was looking through it and I was just seeing what seemed familiar to me. So I saw like the Azure storage and the data side. I knew that. I knew what the machine learning part. I knew how to train my model. I knew how to evaluate my model. But all the other stuff, endpoints, I saw things like data sanity tests, unit tests. I needed to publish things, whatever that meant, something about artifacts, something about pipelines, this thing called Kubernetes that I'd never heard of. And for me, this was extremely overwhelming. And, as I said, I'm lucky enough that I have a lot of other specialists in my team that are able to help me with this. So I got their help in. But what I've noticed over the years is that in the beginning, it was very much like, oh, we don't really expect you as data scientists to set up the Kubernetes services or to be able to deploy your model. But the last 2 years, these expectations have come with the role. So they are expecting data scientists to be able to build a pipeline, to deploy that pipeline, to monitor a pipeline, to make endpoints, to make APIs, which is quite overwhelming, to be honest. And I think this image really kind of captured it because it really felt for me that when I know a lot about the experimentation phase, so about the data acquisition, maybe some of the business understanding and the initial modeling. When we came to developing, like I knew how to model it and I knew that, okay, I now have a certain accuracy, so it's good enough, so I'm done. But all the other stuff, testing, continuous integration, continuous deploying, and actually operating the model, which meant there needed to be a feedback loop of what the model was doing. And with the new data coming in and, kind of working together with an operations department, something which I'd never done before. And actually, when you look at it, this is something that's been happening for years with developers as well. And developers created this thing together with operations called Devops. And it's finally, since a year or two, is starting to rise up for data science as well. There are many names for it. Some people call it data ops, AI ops. I'm sticking with ML ops because it just rolls off the tongue a little bit easier. And ML ops really is a tool to kind of help you with your ML model lifecycle, your machine model lifecycle. So MLOps is really just DevOps for data science. And it's about the data science department and the operations department collaborating with the ultimate goal of actually getting your algorithms and models into production. And I think we all know that the hardest part of machine learning really isn't the machine learning, it's more the data. I wanted to share this with you because what happened with me when I was going to these companies it's still actually is this usually this happens. I walk in, I introduce myself and say, hey, I'm Megan, I work for Microsoft, I'm a data scientist. And the companies are, Megan, this is perfect because we have data and we want to do machine learning. How are we going to do this? And it's always, again, this is like the magic black box that I was talking about, right? They really think that you have these data scientists and they're going to build this magic black box and you have this data and then we're done. And we all know that the reality is very different. At first, you need to collect data. And even this step goes wrong many times. I've had many companies that say, we have data. And then when we're ready to start working with it, I'm saying, oh, can you show me the data? What kind of data do you have? And it turns out they're not actually capturing the data. So they think they have data, but they're not saving it somewhere. Or they have the data and they have saved it somewhere, but the person who set it up has left the company, so they can't actually access the data. I can't tell you how many times that happened. And even if there is the data, there is a kind of the next step, which is the pre-processing. So the cleaning and the structuring of the data and doing some quality assurance on the data. And this is something that takes up 80% of any project time. Some companies have now said that this is a separate role, actually, and I keep forgetting the name that they call for it, but some companies are saying now we have a separate role, a separate department full of data engineers, for example, that are just working on cleaning the data. And then we have a very small group of ML engineers, which are actually building the algorithm. I think that as a data scientist, you do want to be part of the process of pre-processing the data, because if you don't know what was in the data, it's going to be more difficult to build something sound out of it. And once you actually have pre-processed the data, it's first about just getting those insights of the data. Sometimes that's even enough. So for example, I had a company that went to me and said, we want to do machine learning, when all they really wanted was to get a Power BI dashboard. And that was enough to kind of fulfill their need and their business use case. And once you have the insights into your data, it's really about setting the right questions. What do we actually want to know? And then also what is already available. So look at the pre-built AI, look at the simplified machine learning, because maybe one of those APIs can do the work for you and you don't need to do the whole custom coding for months and get something to work. And then, it's actually building the model and it's finding the patterns and seeing if it's accurate enough. And, the last step is also optimizing and improving the model over time. And here's that image again that I just showed is, MLOps really kind of tries to take you up to the next steps. So really tries to help you with doing that continuous deployment of your model and helping with version control and actually helping it getting it into production and your model doing something. So in the example that I gave earlier of working in retail, making an image recognition model, maybe your model does enough to, I don't know, help customers choose better pants. Just making something up here. But we need to apply it or work with operations to bring it into production and ship that model and have it applied to something. So as I said, like MLOps is basically DevOps for data science. And for those that aren't familiar with it, I kind of want to take you through what that literally looks like. So the process that an app developer would go to is they collaborate via GitHub and they build an app in a DevOps environment. I'm going to be talking here about Azure DevOps because I work for Microsoft, so it makes sense. But, I'll have a slide where it shows other DevOps environment and solutions that you can use as well. So they build it, they test it, and with testing, it also means doing like some penetration testing and seeing if it's secure enough. Then the developer releases the application and then they monitor the application. So what does it actually look like for the data scientist? The first step is working in GitHub or working with Git, because again, GitHub is not the only place to work in. And it's really about writing your code, getting your data set, maybe creating some virtual environments to work in, and versioning that environment. And for those that maybe haven't collaborated that much anymore, that means making sure that everybody's working with the same Python packages, the same Python versions, and being able to reproduce that. So if, for example, for whatever reason, I leave the company or I get ill, there's somebody that can actually continue my work, which is also why code quality is so important, because if I leave, you need to be able to make sense of my code, right? And then the second step is building the app, which in the case of data science just means training your model. Again, you can use things like AutoML, so that can help you set the parameters. But this is, this is training the model. So you have pre-processed the data, you know what you wanted to do, and now we're going to make sure it reaches a certain accuracy or it actually does whatever we expect it to do. Then we're about to test the model, which is the training part of it, the testing part of it. And here it also means kind of validating the model. When you're working in a group, it also means making sure that everybody's code reaches a certain level. So for example, if I'm working with 5 other people and my code has reached the highest accuracy, it means that we're going to ship out that code to the rest as well, so they can improve upon that version, for example. And then it's about releasing the model or deploying the model. And that means you need to kind of package it. This is also where the infrastructure comes in. So when we're going to start talking about containerization, which is a whole topic by itself, and we're going to deploy it. And once it's been deployed, we need to monitor the model. And again, monitoring the model also means at times retraining the model when there is, for example, data drift, or when something weird has happened, or when you simply has done something with your code that can improve the model. So it's kind of a vicious circle that goes around. And then with vicious, I mean it in a positive way. And again, I'm mentioning here MLOps with Azure machine learning, but there are a lot of other ML platforms that people have used internally. So there is a TensorFlow extended, Facebook uses Facebook Learner Flow. Uber uses something called Michelangelo. And again, you can also build your own MLOps platform with the tools that you find handy or the tools that you are already using. And there are many, many combinations you can make about this. And I will paste these ones in the meeting chat as well. But these are just some resources to get started. So to be very transparent, I think MLOps hasn't reached its final destination yet. So for example, what I've done is, again, I'm a traditional data scientist and I have gone to the MLOps GitHub. We have one for Python and I took that one and it basically has a quick start to kind of take you through the steps. So I went through them and I was extremely overwhelmed because although I had learned or had read about things like containerization and key vaults and security, actually applying them is a whole different thing. And I'm not saying that we're in the future, the data scientist 2.0 is going to have to be able to do all of these themselves, but I think there are concepts that are good to be familiar with. So the MLOps GitHub is really a good place to start. It kind of takes you through everything. And it's also a great place where you can log issues or ask questions. There is a reference architecture you can find as well. Again, this is from the Azure perspective. So from the Microsoft perspective, there are probably ones that you can find for other platforms as well. I've actually written an article about my experiences with MLOps and kind of going through those steps as a data scientist, where I also dig in a little bit deeper about why I think MLOps hasn't reached its final destination yet. At the moment, it really feels like they've taken DevOps and they've just copied it and applied it to a machine learning environment, and that's MLOps. And I think there's still a lot that we can do to make it a little bit easier. And there are still gaps. So for example, if we're talking about unit testing in Python or unit testing for data scientists, there are some people that have posted about it and there are some packages that you can find, but we really haven't settled yet on this is the best way to do it. So I'm super fascinated by this. I'm trying to contribute where I can with this, but it's super fascinating. And if podcasts are more of your thing, Twimmel is an amazing podcast, which I would recommend to anybody. And they did a podcast about MLOps. I think it's even 2 years ago, which I would definitely recommend listening to because it really talks about, again, I mean, this is Jordan Edwards, he's from Microsoft, but it really talks about kind of the challenges that they are facing and how we're dealing with it and how we're also asking the world kind of to contribute, because we're really no longer as Microsoft in the Balmer age where we're trying to tell you what to do. We really want to learn as well, which is also why I think it's great it's on GitHub, because then you can contribute to whatever you want. So I went through this quite quickly, but it's also because I really would love to hear your questions and have a little bit of discussion. And if you just look for Megan Bloemsma, Google, or Bing me even, you can find me in many places. And if you want to have a discussion about it, you can just send me a message on Twitter or send me a message on LinkedIn. As I said, it's not static, so we're not there yet. And there's a lot that we can learn. And that's kind of what I want to do. So I'm going to stop sharing my screen. And I'm going to make sure I have it on my right screen as well. So yeah, Nazia, how do we want to do this? Should I just go through the meeting chat, or do you have some things highlighted already?
All right, Megan, thank you for actually, taking us through, the pre-built AI, talking about AutoML, and also, talking about the different roles that are coming up and the challenges that most of the data scientists are facing these days.
Yeah.
I mean, this surely will help people who are planning on stepping, into the data science field or looking at transitioning, and also sharing your experiences, about how it is better to not just get overwhelmed with what problem is put forward, but look at, what you can relate to. So we are opening the questions so the learners can ask questions. Megan, is
actually, what you just mentioned, maybe it's good to then dig a little bit deeper about the data science roles and the experience I'm seeing there, especially for people who are starting out and are doubting what is happening. And then I can also talk a little bit more about what the pre-built AI actually means. I think that might help a little bit because these are questions I'm getting a lot as well, if that's okay.
Yes. Sure. No worries.
So we talked shortly about the data science roles and how we're seeing a lot of different roles happening, right? I think, again, talking from my own perspective, we can kind of summarize it in a couple of ways. What I'm really seeing is that on the one hand, they're creating different roles which are very much about the pre-processing of data. So these are roles that are really busy with, they're getting a huge chunk of data, can be any kind of data, and these need to be cleaned. So we need to look at outliers, at missing values. We need to look at, is the data being recorded consistently? And it's really about cleaning that part. I see that kind of as a role that is starting to, in a way, almost become its own field. Then we have the next step of getting insights into the data, which can go two ways. It can go either the data analyst way, or it can go more the visualization way. And that can be either a BI, so business intelligence, or data visualization, or however you want to call it. These usually are very separate roles as well. Already there, it's starting to get blurry because data analysts are very often also tasked with actually cleaning the data. So I guess there it really depends on how big the company is. So for example, if you have an enterprise that works internationally, it makes sense that they would have a separate team working on cleaning the data and a separate team on getting those insights, just because it's so much. If it's a smaller company, there's a very high chance you will be doing multiple roles in one, right? So we have the cleaning, then we have getting the insights, and then the last step is actually building the models. I've seen many names for this come by. I think the most prevalent one I'm seeing is a machine learning engineer role. And that can mean a lot as well, because it basically means you're building the models, but that does not say what kind of models they are. So they can be image recognition models, they can be natural language processing models, they can be all kinds of things. So there are specializations there as well. We also talked very shortly about a thing called pre-built AI. And I feel like this is really something that the big tech companies have introduced because there still is a shortage of data scientists. So there are a lot of companies out there that do want to do their first AI projects in whatever form they may be, but maybe don't have the budget or don't have the expertise in-house to do these things. And this is why you have pre-built AI. So originally, it really is targeted for people that are not data scientists themselves, but do want to dabble in it a little bit. And they work with APIs. And an API is basically an endpoint, so a place on the internet where you send your inputs. So for example, if you want to do image recognition, you send your image there. The API is just an endpoint, right? So on the back, the tech company, so for example, Microsoft is running the algorithm and it's training and testing, and it will give you the output. Something that I would recommend you downloading is something called the Intelligent Kiosk. It's from Microsoft again, which makes sense because I work there, but it's basically a free demo environment you can download where you can try these things out. So you can try out the facial recognition thing where it will tell you, I think you're most probably a lady in this age range, or you can do speech to text there. So you can say something that will automatically put it into words and maybe even automatically translate it. So it's called the Intelligent Kiosk. Just download it because it gives a really good insight into what this pre-built AI actually is. So I hope that clarifies it a little bit. So Nazia, what was the first question?
So the first question was from Gaurav. So he is asking, so, it's like, so do you suggest someone doing a master's or a PhD in data science if they want to start off with, working in the field?
This is a really difficult question. Doing a master's or PhD, I think, is always a good thing. Education is always great. But I wouldn't go as far as saying you need to have a PhD in data science to do data science work. That being said, it will be a little bit harder to get into the field, most probably. Even though there is a shortage, I think companies are still kind of they're asking a lot from applicants, which is not necessarily a good thing. But again, to summarize, I think education is always a good thing. Do you absolutely need to have a PhD in data science to get to work as a data science? I don't think so.
That's a wonderful explanation, a nice way to put it forward. There is another question that we have, which is asking that, do data scientists also need to know about Devops or MLops?
Well, this is the interesting question, right? I think that the role of data scientists will change so that you will need to know about MLOps. Not necessarily that you will need to be an expert in all of the components, but that you do need to kind of learn to work together with people and do need to be conscious of what it means to get your model into production. I think this is more of an experience kind of thing. I don't think, at least, okay, let me go back one step. There are many resources online that can help you learn about MLOps. There are the resources that I put in the slides, which I will copy in the meeting chat before I forget. But there are also, for example, websites like DataCamp. DataCamp.com is a really good place. They have a whole course on Git for data science, which is a really nice place to start. There are, well, honestly, like if you just Google or Bing for it, there are many places where you can learn about MLOps. Because we aren't really in the end station of MLOps, I personally haven't found like a certification for MLOps yet. So there are events you can attend. There are websites you can go to. There are articles you can read. But because we're not sure yet kind of what the best practice is, it's a lot about getting experiences and just doing it. I hope that answers your question.
That was quite helpful. I'm sure it helps people in attending the various seminars or attending various networking events and trying and understanding whether they would really need to know about MLOps. So how useful is Microsoft Azure? Asks another learner, because according to him, he's saying that I have not seen any company asking for the skills for Azure.
I actually think that's a great question. The thing is, Azure, it's not like one product, it's a whole platform. So Azure is basically the Microsoft cloud. Just like you have the Google cloud, just like you have the Amazon cloud, the Microsoft cloud is called Azure. And it entails much more than data science. So it's, I'm trying to see how I can explain this. It's kind of what the company decides to build their technical infrastructure on. And that can be Azure, that can be Google, that can be AWS, it can be Alibaba Cloud, it can be a lot of things. What we are seeing is that especially enterprises are moving a lot to Azure, but it depends on the company you're working for. So it's very possible that you work at a company where they maybe not be using Azure, but a different kind of cloud. And I think that's fine.
Okay. So that was one. And we have a couple of more questions coming in. So another question is for you, which asks, what was your process to be hired by Microsoft as data scientist?
So what I did is that during my master's, I applied for the traineeship program. It was called MAC back then, but right now it's called Aspire. I would recommend it wholeheartedly. I really enjoyed the traineeship, and it gave me a great opportunity, not just to get to work, but also to actually get some extra training and to learn a lot. But how I got hired there is I applied. I went through 3 months of different rounds, and eventually they wanted to have me within the company. So it's really difficult for me to say anything about that. Yeah, I applied, I prepared, and I was lucky enough to get in.
That's a fair explanation, Megan. I mean,
I wish there was a magic bullet for this.
Yes, you put it in a very nice way. So we have a question which asks, does your work involve working with Microsoft's open toolkit called Fairlearn? If yes, in what ways are you working with this toolkit?
Amazing question, because ethics and AI is so incredibly important. So yes, within Microsoft, we do have several kind of kits or packages that we bring out that you can use to kind of check the ethicalness of your models that you're building. So we do have Fairlearn, we have a couple of others. And what they do, for example, is they go through your data set and see how biased is my data set. Is the population being represented well? And it's asking some questions about the model that you're building, like, have you thought about ethical aspects of that? I have worked with it, but it depends very much per company. So in my job, I have about 10 companies on average every year that I help throughout the year, and then other like extra companies that I just help like on a one-off basis. I try to bring ethics into every conversation that I have, because algorithm bias is a huge issue. It's something that we should all be aware of and something that we should all be working on. I don't want to no, I'm going to do some shameless self-promotion on my website, meganbloemsma.com. I have written an article about how algorithm bias, what it is and what we can do about it. There's an article coming up as well about all the responsible AI kits that are out there that can help you with this. So I try to get all the companies that I work with to use the Fairlearn kit or the other kits. And most of the companies are susceptible to it, luckily enough. So yes, I do use it.
We have another question, which is, can you please make it clear that 5 years from now, what companies would be expecting from a data scientist? And what are the things that will be needed to know? Like, what should we learn today?
Good question. But I can look into the future. So I can only give you my estimations of what I think will happen based on my experience. And based on my experience, I think the role is going to expand. So we're going to expect more from data scientists, and the expectations will lie in that we're expecting them to have software engineering skills, basically, and that they know a little bit more about mostly, I think, containerization. Do I know that 100% for sure? No, I do not. And I think it differs per company that you're going to work with. I think it might even differ per country that you're working in. But I would be very surprised if the data science role stays the way it is. So we're currently expecting a data scientist to do the pre-processing and cleaning and to give some insights and maybe to build a model. I think those responsibilities will be expanded to those software engineering skills. But that's my opinion.
Okay. All right. So, Megan, we have a similar question to what you had answered before, which is asking, is it good to join any company just after completing your graduation, or should you plan on, pursuing your master's in data science?
Again, I think education is really important. But at the end of the day, this is your own choice. I think if we're talking about education versus experience, there are a lot of companies that might value experience more, but it depends on what you want to do as well. And it depends on what kind of experience you're getting. So I know this is not like an answer that you'll be happy with, but it really depends on you. So if you've done your bachelor's now in whatever you've done, and you want to get to working into it and you have a job opportunity, I think it's very fair to kind of see what will I be doing in this job and what will I be learning for the upcoming year, and then compare that to what you'd be learning in doing a master's. I'm from the Netherlands myself, and I'm noticing more and more that, doing a master's or doing a PhD, it's a really great place to start, but it does not guarantee you a job. And again, like the master and the PhD is very focused on more the academic approach of data science, which is super valuable, but it's not necessarily what companies are looking for.
All right. We have one more question here, and this is coming from Maya. She's asking us, I teach ML to business and social science students. I do it the classical academic way that you described. How could I bring more real data science experience in the class?
I love that question, Maya, and I'm so happy you're asking this, because I really wish I would have gotten a little bit of more of this from my professors at the uni. You probably already know the site, all of you, but I think Kaggle is a really great website. They have data sets on there. They in some cases they have really good use cases there. Some of them are maybe not the best use cases, but I would go to Kaggle.com and pick out a competition there that seems to be a little bit more applied, so that it's not just about who can reach the highest accuracy, but maybe it's about like how can you apply this model to do a certain thing. And I think it's a small thing, but it really helps me. It's really about asking, why am I building this model? So to go back again to the example of the image recognition model in retail, why am I building an image recognition model? Am I building it because it will help customers make decisions? Am I building it because maybe I really want to work with TensorFlow and I found this really cool new package and I want to try it out? And another thing but that's more from the business perspective, what I try to teach the companies that I work with is start with your customer's question. So if you are a retail company, and what are the blockers of your customers? For example, if your customers are saying, we're having trouble with customer loyalty, so people are not just shopping at our store, they're shopping at 10 different stores, then the question can be, okay, how can we increase loyalty? And maybe a way to increase loyalty for these customers would be personal recommendation models. And then a personal recommendation model would make more sense to build than an image recognition model. But to come back to your question, Maya, about trying to get a little bit more applied data science in there, take a look on Kaggle and see what's on there. And Google actually built an entire search engine just for data sets, which is also a really great place to just get some data on maybe not like I don't want to call them like the typical academic data sets, but I do want to say like more the data sets that are maybe just different kinds of topics. I think that would be a great way to start.
All right. So we have yet another question. I think this is with regard to MLOps. So when you say collaborate in GitHub, isn't it training the model? If not, is it just to do pre-processing alone? I'm not sure if the question is complete, but this is a question that's coming from one of our learners.
Yeah. I'm also not sure if I completely understand your question. So if you want to add on to it, please put it in the meeting chat. But GitHub really is just a place where you as a team can place your code and collaborate on it. I don't want to get into it too much, but how it works, say, for example, if Nazia and me both have a piece of code, then we can upload it on there. And if that code works well, and with that I mean it doesn't break the code that we already have and it's adding value, then we can merge it to the master branch. And that master branch really is in a way, it's almost like the ultimate source of truth. The master branch is the thing that we're going to deploy, and is the one piece of code that consists of multiple pieces of code of both Nazia and me, but it's the one piece of code that will eventually be packaged and will be deployed. So when we're collaborating on GitHub, it's collaborating on code. So that code can be both the pre-processing, and that code can also be training the model.
Thank you so much, Megan. I think we've received as many questions as we could. We're not seeing any more questions from the learners. Let's give them okay. So the person has clarified his question.
Oh, good.
He's saying you mentioned AutoML and GitHub is two separate steps, hence asking the role of each step.
Yeah, perfect. So the difference between AutoML and GitHub. GitHub is a platform where Git is the coding language. So GitHub is just, again, it's the place where you store your code and where you can collaborate on the code. AutoML is actually more of a product. So it's a product that we have in Azure Machine Learning. And what AutoML does is it will parallel test different mathematical models for you, and then it will give you the results. So for example, if I want to do classification, you can select kind of which algorithms it will need to test for you on your data set. It will parallel test them, so that will save you time. And then it will tell you algorithm A, B, C, D, E, this is the accuracy that we got. And based on that, it can kind of help you make a decision on which algorithm you want to use. How I always used to do it, I would also test those mathematical models, but I would do them one by one with my own written code. So AutoML is a product that is part of Azure Machine Learning to kind of speed up that process. And GitHub is a place where you collaborate on code, and it's a platform.
I'm sure that answers the question there.
I hope
so. Thank you so much, Megan. Yes. So we're almost, nearing the end of the session, and I really thank you for taking your time and answering these questions, and also doing such a wonderful session for all of us, especially in understanding how one can step into data science, or how they can transform and look at the different options that are available. So we also have Maya, WiDS Brussels ambassador, with us. So she'd like to say a couple of words. So I'm just adding her to the stream. Maya, you're on air.
Yes, yeah. Thank you so much, Nazia. Thank you so much, Megan. learned a lot that I hope transfer to my students. Like I've been academic all of my life, so it's always great to hear from the people who are in the field and doing the hard job.
Yeah, and again for you, but also for the people listening, again, like there's a really great data science community and a really great MLOps community. So reach out to those, like message me or message people, just look for hashtag MLOps, go to the GitHub repos, and there are great places where you can learn even more, because I'm also still learning every day with this.
Oh yeah, I think we are all lifelong learners, basically. Thank you so much for that. Just to remind our audience, we'll be having exciting talks for the next 3 weeks, Tuesdays and Thursdays at this time. So the next one is next Tuesday at 2:30, and it will be about the natural language processing techniques in the airline industry. And you can see there, thanks Nazia for putting that on the screen what follows. Thank you so much, and see you next time.
Thanks everyone, really enjoyed this.